All right, welcome back. So the next problem, excuse me, the next problem, number 54. Uh, 54 says we have find, oh, sine of u plus v, okay, given that tangent u equals 3/4, sine v equals 5/13, and u is in quadrant 3, and v is in quadrant 2. Okay, so that means we're going to have to find the stuff for u and v. Okay, so I love these problems. These are like my favorite things in pre-calc. Maybe not my favorite, but they're among them. Maybe top 10, top 20. No, top 10, definitely. Okay, so let's go ahead and I'm going to draw a picture. But first, let's do the equation. So sine of u plus v. Remember, we're using the sine addition formula. So I'm just going to write it. It's sines they mix the sine and cosine, and they have the same sign. One thing to watch out for when using u and v as variables, it's very easy for my v's to look like u's and my u's to look like v's. I'm going to keep an eye on that, but if you have that issue, maybe just change the variables around. I'm just saying, okay, you can do that. It's not going to harm your math development at all. Now, we need to find these values. Now, sine of v, I know. Sine of v is 5/13. That's the only thing I know. Okay, well, let's draw the pictures. So let's draw u. Tangent of u is 3/4, and u is in quadrant 3. So that means I'm going to have it down here. Okay. Remember, what the hell? Remember, opposite is 3, but that's a negative, and adjacent is -4. Okay, so this is going to be 5. So I'm going to need the sine and cosine of, this is u, sorry. Yes. So sine of u is -3/5. Cosine of u is -4/5. Okay, I'm going to do the same game with v. Okay, v, sine of v is 5/13, and v lives in quadrant 2. Okay, so that means we're going to have opposite being 5. Sorry, that's an ugly 5. 5, and hypotenuse being 13. Make sure I have the right sign with a G on that 5, and that's correct, that is positive. So now that's a 5, 12, 13 triangle. So my x should be -12, okay, because we are in the second quadrant. So the y is positive while the x is negative. Okay, so let me just write out here. This is my V triangle. Okay, so sine of V is 5/13, just like we had given in the problem. Cosine of V is -12/13. Okay. All right. Okay, so now your sine addition formula is going to give you -3/5, that's sine of u. Cosine of v is -12/13, plus sine of v is 5/13. Cosine of u is -4/5. Okay, putting those together, I'm going to get 36/65 minus 20/65, 16/65. Okay, not bad, huh? Let's try, I guess the last problem we'll go ahead and do. Find the exact value, and this is 76. Find cosine of the sine inverse of 3/5, okay, plus tan inverse of 2/3. Okay, so this is actually very similar to this last problem. Okay, we're going to call theta 1 the sine inverse of 3/5. And theta 2 the tan inverse of 2/3. I'm running out of space here. Let me make this, make a little more space for us. Resize this just a little bit. Okay, that'll be plenty of space. Okay, back to it. Okay, so we have cosine theta 1, sorry, plus theta 2. And now remember, we have to remember that cosine addition formula. Okay, so the cosine addition, they have cosines together and sines together, and they have the opposite sign with a G. Okay, so cosine theta 1 cosine theta 2 minus sine theta 1 sine theta 2. So we need to find the cosine and sine for these things. Now, we're going to do the same thing that we did with the last thing. We're going to draw a couple triangles for each of these. Okay, now these are actually easy. I'm kind of wish we may have to do another one just because I want to show you guys something. In fact, we will do another one after this. Let me just show you how these triangles work. So here's our theta 1. Oh, that's interesting. I know what happened. Okay, so here's our theta 1 triangle. Here's our theta 2 triangle. Okay. Now, theta 1, because this is inverse sine, okay, that means we're going to be in the first and fourth quadrants. So because these are both positive, that's why I think this is not as interesting as it could be. They're both going to be in the first quadrant. So I can easily draw this. This is going to be 3, 5, 4 triangle. This is going to be opposite over adjacent for theta 2. So that this is going to be 2, 3, and then 4 plus the square root of 13. Okay, so how am I getting these numbers again? Remember, so when I say that, for example, theta 1 is the sine inverse of 3/5, what I'm saying is that the sine of theta, where this is my theta 1, sine of theta 1 is 3/5. Okay, so opposite over hypotenuse. Here, when I say theta 2 is the tan inverse of 2/3, what I mean is tangent of theta 2 is 2/3. And because theta 1 or sine inverse is stuck in the first and fourth quadrants, I know I have to draw it over here. Same with tan inverse. Okay. So running this through here, we get cosine theta 1 is 4/5 times cosine theta 2 is 3 over root 15 minus sine theta 1, that's 3/5. Sine theta 2 is 2 over root 13. So that's going to be 12 minus 6 over 5 root 13. So that's going to be 6 root 13 over 65 after I rationalize it. Okay? 6 over 5 root 13 times root 13 over root 13. Okay? Okay? All right, I'll see you in the next video. One last video.